In this video, I wanted to wrap up the discussion on how would we select the quota and what are our valid options. And previously, I talked about different types of majority quotas, and even sometimes in this situation, there can be problems, and that's kind of the idea of the following terms. But the basic restrictions to the quota, there's always a set of numbers that are allowable and a set of numbers that are not allowable. And basically, the quota needs to always be at least a simple majority and at maximum equal to the total number of votes in the system as a whole. So basically, let's just look at a couple cases in which that wouldn't happen, but we refer to anarchy as a situation when the quota is set to be too low. Or basically, let's say we set the quota to be underneath a majority. So like in this particular case, let's examine a situation where we have 4 voters with weights 7, 5, 4, and 3. That would make a total of 19 votes. And a majority of 19 should be 10. But let's say we were to, which would be calculated by V over 2. But let's say we round down and round 9.5 down to 9 and set it underneath a majority. Well, basically this would be a problem because let's look at a particular example. Let's say that player 1 and player 4 formed one coalition, and player 2 and player 3 formed a different one. So, you know, how we would write that would be 7-3, and separately 5-4. And so the issue here is notice that, well, we would say that this coalition of players 1 and 4 is a winning coalition, right? Because it has enough votes to make the quota. But so is coalition 2. So if group A says yes and group B says no, well, what would happen is both would simultaneously pass and fail the motion. So the problem is we have anarchy. We can't make both decisions. So what do? The system falls apart and fails when the quota is set to be low. And similarly, if the quota is set to be too high, or let's say that we take a quota and set it to be larger than the votes of the entire system. Like in this case, we had 19 votes, but say we set the quota to be 20. Obviously, this is going to be a problem because even if all 4 voters say yes, there's no possible way they can get to 20 votes. So it would be it'd be an unwinnable battle because it can't make 20 votes if there's not that many votes in the system. So obviously this is a bad situation, and we would call this gridlock. And technically, the idea of gridlock is just it's impossible to get anything done, or it's virtually impossible. As is anarchy, it's too low, anything can happen. But basically, the conclusion from all this is there is a necessary range for the quota, and your online homework questions will probably be asking you, so what are the valid options for the quota in a particular situation? But where you always want to start is, well, what's V and what's a simple majority? What's V divided by 2? And that's going to be your baseline range beyond there. Now, there's other factors that can complicate the situation. And that's kind of what I wanted to address the remaining few terms from section 1. So we refer to a dictator as an all-powerful player in the system, basically a person who is in complete control of the weighted voting system. And this is always, you can tell this mathematically by if a player has a weight which exceeds or is equal to the quota. So looking at this example, player 1 has 13 votes, but the quota is set to be 12. So you can imagine that if player 1 says yes or forms their own coalition, they're going to pass the motion by themselves without the need of anyone else. And at the same time, if we look at everyone else, the sum of all of their votes makes 10. Even if all 3 other players group together to try to pass the motion, they don't have enough weight to pass the quota without player 1 coming along. And so player 1 is called a dictator here because they are in complete control. If they say yes, the motion will pass. If they say no, the motion will not pass. Basically, no matter what these other players do, they do not have any control. And this is obviously a problem in a weighted voting system because this defeats the entire purpose of the weighted voting system. The purpose is to ensure that everybody is coming together to make a decision, but why bother if one player is all that matters, right? You might as well just ask player 1 what they want and be done with it. It's not, really a group decision. And a lot of times, these can happen in the real world where you have, like, kind of like I was saying in chapter one, you kind of have an illusion of democracy or an illusion of a vote happening, when in reality it's kind of predetermined due to various settings. And it might not be so obvious that, you know, someone has enough votes to completely control it, but you could have enough bias to where no change will ever happen, which is a huge problem in, um, for example, say with the United States, you know, Senate or something trying to make a decision. If there would be too many Democrats or Republicans, it's basically in control of by one party. And while there is a vote, technically it's not nothing's going to happen. And you can kind of see that with the impeachment process, where uh, the Republicans had control of the vote, and there's really no way it would be overturned um, unless the senator literally went against their party lines, which actually one did, um, in that case. But it's very rare because it's usually political suicide to have a party affiliation and then go against it in any vote at all. So it's a huge problem with the U.S. system. But again, trying to not get too much into politics in uh, the U.S. specifically. Anyways, a couple other situations which are not quite as dangerous to that above situation is when a player has veto power. And sometimes it actually might be fair to have veto power in weighted voting systems, and sometimes it might not. It just really depends. And this is a case where basically one player has a lot of the power, but they're not in complete control. So like notice in this case it's very similar. We have the quota set to be 12, and player 1 has 11 votes. Now by themselves, player 1 could not unilaterally pass the motion. So they're not a dictator because they'll need at least one other player to come on their side, meaning that those other players do have some power. But at the same time, the reason why the player has veto power is if we look at everyone else's vote, the sum of all of their weights would be a total of 11. So notice that even if all of these voters voted yes, they still wouldn't have enough votes to make it to the quota, which is why player 1 has veto power. So the idea of this is that if player 1 says no, the motion will not pass, and that's what we call a veto. Veto power is like saying, okay, if this person says no, it's not going to happen. And the president of the United States has veto power on a lot of things, which is like even if it goes through the process of other votes, the president can still shut it down after all is said and done. And that's kind of what would happen in this case. Even if all these other people say yes, it doesn't matter because they at least need player 1 on board. And if you're looking for a more mathematical way of doing this, the way you can see if a player has veto power is if you add up everyone else, if the sum of their weights is less than the quota, that other player, in this case player 1, would have veto power. And basically, it's just a way, if it's impossible to pass without them, they would have that veto power. Anyways, so yeah, that's an example of that. But it's not a dictatorship because they can't control it by themselves. So it's not quite the same, if you see what I mean. And the last term from section 1 is what we call a dummy voter, which has nothing to do with the intelligence of the voter, but more to do with how much power they have. In math, the term dummy variable or dummy index often means something that is kind of irrelevant. It's not really something that actually is part of the problem, but it's just sort of there nominally. And that's kind of the same meaning when we say dummy voter in this case. So it says a player is a dummy voter if they have no power in a weighted voting system. And actually, going back to example from the dictatorship up here, we would say these three players 2 through 4, were all dummies in that system because, as we discussed, player 1 had complete control. Player 2, 3, 4 didn't matter. So this was an example of one player with 100% power and the rest was 0, hence being dummies. And actually, when you calculate the Bonzoff power distribution, what we're going to do next, you can tell if someone's a dummy because they'll have 0% power, and you can tell if someone's a dictator because they'll have 100% power. So these terms are very easy once we've determined this quantitatively. Veto power is a little bit more difficult, but you can follow this guideline in order to do that. But let's look at another example for a dummy voter. Let's say we had 4 voters, each with votes 10, 10, 10, and 9. We're all trying to make it to the quota of 30. So if we were to look at this, well, obviously if players 1 through 3 said yes, they would make the quota. Um, but for example, let's say player 1, 2, and 4 each said yes, that'd be 29, they would not make it to the quota. So if we're looking at all the potential ways for this to pass, well, either all 3 of these people would need to all say yes or all 4. And that would be the only 2 scenarios, those would be the only 2 winning coalitions in this particular system. And so we would say that player 4 is a dummy in this system because it doesn't really matter whether the 9 comes along or not. We need at least 30 votes. That 9 will not add into the other numbers in any beneficial way to actually make the quota pass. So it's essentially this player with 9 votes is a dummy because it doesn't really matter. There's no situation in which their vote can be meaningful. Kind of like in this example, those votes will never be meaningful to make it to the quota. And determining a dummy voter is kind of hard to do just by looking at it, but these are some sort of more obvious examples. And sometimes it's not always obvious whether someone's a dummy or not, and that's why we want to go through the analysis process to actually figure out the bonds-off power distribution. And sort of to wrap up all of this, before we get to the nitty-gritty of the bonds-off power distribution, is that there's some problems that arise that are not necessarily obvious. But basically, one point I wanted you to sort of notice is that the number of votes in a system can be deceiving and does not tell the full story. Sometimes the power that players have is not necessarily proportional to the amount of votes they have. Like looking back at this example, let me see if I can clear all this ink because it's getting in the way. These 3 players had 10 votes. This had 9. They like without really thinking about it, they seem like they would have very similar levels of power because they're only 1 vote difference. They're very, very close in actuality. But if we were to actually go analyze how much power they have, each of the 10s would have equal power because they all have the same weight, but the player with 9 has no power. And it's a pretty big difference between having influence and not having influence, between having power and being a dummy voter. And that's why sometimes numbers can be deceiving as well. Or, in the case of players can have votes and have no power, or sometimes players with different numbers of votes can actually have the same power. Like let's look at another situation in the slide. But let's, it says a player with 1 vote can have just as much power as a player with 10. And if we look at this particular series of numbers, 10, 10, and 1, notice that the player with 1 vote is kind of interchangeable with the player with 10 votes because let's say players 1 and 2 said yes, they would pass the motion, great. But in the same situation, if player 2 and 3 or player 1 and 3 said yes, they would still pass the motion using those combinations. So even though one player has 1 and one player has 10, it actually doesn't really make a difference because really all that's needed in that with that particular quota is 2 people to say yes, and they're kind of indistinguishable. So at the end of the day, these 3 players would have equal power, which again, it would not necessarily seem that way due to the vast difference in the number of votes. And sometimes, people can have different numbers of votes and have the same power level. Sometimes people can have almost the same number of votes and have widely different power levels. And that's why we have a necessity to actually quantify the power in the system so that we can analyze these things with less guesswork. Because it's probably been, most likely it's been a little bit hard to follow me because I've been jumping around with so many different numbers, and I kind of apologize. But I just wanted to give you a lot of different contexts and cases to sort of see the difficulty and the problems that arise with weighted voting systems.